Okay, so welcome to this lecture. So this is about the problems from 141 to 150. Okay. So this problem is calculated the number of ways. So this is just a counting problem, right? Number of ways. So let's say, so here number of ways such that from a set of 3 distinct items, we just pick 3. Like we just can pick these 3, right? Or just pick 3. The condition is no 2 of them are in same row or same column. So just like that. How many ways? So at the first, we just pick. So here we have six row. So from the 6th row, we just pick 3 rows. So we have so many ways, right? Okay, so now once we pick the 3, suppose like we just pick this 3. So then we just okay. So first one we have pick. So first one for column we have 5 options. So pick each column, right? Pick one of the columns. So there's 5. Then pick another one. So 4 ways, right? We cannot pick the same column. And then 3. So this number is just as that. Okay. So here we want to calculate the expected bonus payment. We just want to find expected payment for those 1,000 people. So among those 1,000 people, it says we split into 2 parts, 400 and 600. So we just split this 1,000 into 2 parts, right? So there's 400 and there's 600. So there's 400 is a low risk driver, and there's 600 high risk driver. Okay. So for those 400, there's low risk. They have the probability that have no accident. No accident, the probability for them is 90. And no accident, so for those people, probability is 80 on 80. Okay. So if there's no accident, then give them $5. Okay. So we want to find how much the expected bonus payment. So this payment is, so from the 400 expected number, how many? Just 400 multiply 90, right? So this number of people have no car accidents. So for them, each one pay $5, right? And then for the 600, so the people for no accident is so many, right? So then multiply $5. Okay. So here we want to find a probability. Probability. Not file. So here, file a claim. So for claim, we have 2 claims, like liability claim and property claim. Okay, So here we have two factors, and there also have some overlap. Some people will apply both of them, right? Okay, so here we just use the Venn diagram. Let's say, suppose this is L liability, and this, let's say, so this is, let's say, this one, suppose this one is property, and outside, so none of them, so we just draw this Venn diagram. Then we put the probability here. So let's say the probability set will find liability but not property is 0, 0, 1. So liability but without probability property, so this part 0, 0, 1, right? So this part is L but not P. Okay. So then O liability is 0, 0, 4. So we can say this overlap is 0, 0, 3. And O property claim is 10%. So this 0, 0, 3. So here is 0, 0, 7. Okay. Okay. So what's the question we want to find? What is the probability we want to find? Is not 5. So this just be the outside. So and not outside. So this just equal 1 minus 0, 0, 7, right? Minus 0, 0, 3 minus 0, 0, 1, right? So this is the other side. Okay, so here we have x and y. Join the density function thus. So what do you want to determine? Determine what? Determine determine the client spends less than 60 minutes at the hedging office. So we want to find this probability, this time is less than this time. Let's see, time less than 60 minutes. We want to find this probability, right? So what is the time? So what is the variable for time t total? So here, so we split time two parts, like the x minutes in waiting room and y minutes with the meet the engine. So the time total time spent in the office is just the x plus y, right? Okay, so we just need to find the probability for x plus y less than 60. So x plus y, so here we say, so x, we just put x and y. So, okay, so x, y larger than 0. So here x plus y equals 60, so that's equals 60. So less than 60 is just this part, right? Less than 60. So for integration, just also find the probability just integration. So this is 60. Yeah. Okay. So we can say for x. So we can say that for x from 0 to 60. So 60 dx. Then once we determine x, determine y. So y should be 0 to 60 minus x, right? So then f x y dx dy. So this probability should be thus. Okay, so we find very clear. This only E, right? So for this problem, we want to find a conditional variance. So when x equal 7.75, so y variable. So we just check, okay, so here, this is like this, x, y. So we split the x into two parts, like from 0 to 0.5 and to 1, right? So y also we just split it into two parts. So totally we just split this into this 4 parts. So, right? So here x 0.5, x 1.51. So when x equal 0.75, so here when x equals 7.5, we put those numbers of density function. So in here is 0.50. And this part 1.25. And so here x between 0.5 to 1. So this is 1.5. And here 0.75. Okay, so when x is 0.75, so we know y is just the two parts. So we can check y, right? So y, so between 0 to 0.5, y value is 75, right? So let's see, like 75. That's the function, right? And from 0.5 to 1 is 1.50. So this is just like a conditional. This one. This is the density one. Conditional distribution. But this conditional distribution. Maybe like this is not a conditional distribution because the total probability may be not equal 1, right? So we need to adjust a little bit. Just multiply some constant or make this total become 1. So let's say we just check the total probability. So total probability is 0.5 multiply 75, right? Plus 0.5 multiply 1.5. So this is total area. So this equal. So here. So let's say so here. We just use fraction. Maybe 0.5 addition 0.51 over 2 half, and this is 3 over 4, right? 75. And half, so 1.5 is 3 over 2. Yeah. Okay, so we can find this equal 8 over 3 plus 6. 3 plus 6, like 9, right? Yeah. Okay, so we know this, so we need to adjust. So divided by 9 over 8. Okay, so we can change this to this. Let's see. So from 0 to 0.5. So this 0.75 is 3 over 4. So we need to divide by this or multiply the 8 over 9 like this, right? Divided by 9 over 8. So this equal, I think it's 2 over 3. So this is just the equal. Here is a 2 over 3. And so from 0.5 to 1. So 1.5 is 2 over or 3 over 2. So divide by 9 over 8, so multiply 8 over 9. So this equal, let's say, equal 4 over 3. Yeah. So here is 4 over 3. Okay. So this is density function. Okay. So we can find what is variance. So we can find like this, we just focus on this ey square minus ey, right? Minus ey square. So this variance. So how can find ey? So just do this integration, right? So y just follow this distribution. So find variance. Okay. So such a problem is just some calculation. Okay. Okay, so this one, let's say, so we have 3 factor, like just 3 factor problem, but like we have 4 factor, like we have 4, like let's say, but this, so we just use the Venn diagram. Okay, just use the Venn diagram. So it is like we can put like, okay, maybe I just okay, so just like that. So we have 3 parts like this. Suppose there's a CBS and then like this and this. So suppose there's a CBS. This part is, so then the NBC, and this is ABC. And okay, so we can put those things like, let's say, usually put this 4. 4, so this number is 4, so put 4 here. 4, watch this 3. And we here outside, so we have this HGTV. So here we have 18. Okay, then like, so we check, so okay, outside, do not watch any TV, right? So we just use the Venn diagram, then we can put those numbers into this Venn diagram, so we can find the answer. So we can find not watch any of these 4. So outside, yeah, we just find outside. Okay. So for this problem, we want to find the calculate the percentage reduction on the variance of the claimed payment. So story is just like that. If we post a deductible D, then the expected payment will reduce, and the variance also will be reduced. So we know the expect payment reduced by 10%. Then we want to find what is the percentage reduced on variance. Okay, so here we just need to find the, let's say, the expected payment and without deductible or having deductible. There we want to check their difference, right? So without the deductible, these things. So suppose we denote this X. This X amount of claim for a exponential distribution. Okay, exponential distribution with a parameter lambda. Okay, and so by exposing the deductible d, the payment, so what is y? Y is payment equal just like that, right? Okay, so from 0 to d, payment is 0, and from here d to here is x minus d. So let's find ey. Okay, ey. So ey equal just x from d to infinity, and payment is x minus d. Then density function lambda is negative lambda x dx, right? So this is ey. So let's use some substitution. X minus d, we just let x minus d equal t. So this integration becomes 0 to infinity t. So lambda is negative lambda. So x become t plus d. So dx just become dt. So this just equal negative lambda d multiplies this integration. T lambda is negative lambda t dt. So this integration is just the mean for exponential distribution, so just 1 over lambda. So we can say this just equal negative lambda d times 1 over lambda. So when 1 over lambda is just x, right? So we have thus ey payment, expectation payment equal negative lambda d times x. Okay, so this is the payment expectation reduced 10% by 10%. So this means I put it to here, negative lambda d equal 0.9, right? Nothing. So this means reduced by 10%. Okay, so now we will check values for payment y. So let's say, so what is ey square? So ey square, same thing, right? So equal from d to infinity, and so payment is y is x minus d, so square. So lambda is negative lambda x dx. Okay. Okay, so same way use substitution, we find this equal just this t square lambda is negative lambda t dt, then but we just take this outside is negative lambda d. Okay, so then this just like x square, right? So x square lambda is negative lambda x dx, just x square. Okay, so what is x square? So we know for exponential distribution is x square. So we know that's values for x equal 1 over lambda square, right? So variance is x squared minus x squared. So we find this x squared is just equal 2 over lambda squared. Okay. Okay. So we find. Let's see. I do not. Okay. Let's see. Okay. Let's put it here. So we can find what is Vy squared. So Vy, not Vy squared, Vy variance of y, so equal this Ey squared, so negative lambda d times 2 over lambda squared minus Ey squared, so Ey is negative lambda d squared, and multiply the x squared 1 over lambda squared. So put them together. Okay, so we find this equal just negative lambda d is just 0.9, right? So we find this equal 2 times 0.9, so minus 0.9 squared. Excuse me. So 1 over lambda. So this is just the sorry, Vx. Okay. So we can find how much. How much percentage reduced? So this number, the 2.9, 1.8. So this, let me finish here. So this number is 1.80 minus 0.9 squared 0.81. So this equal 0.99. Okay, so we can say so 1% reduced, right? So the answer is 1%. The answer is says 1% reduced. Okay. Okay, so now let's move to 148. So it says the number of hurricanes that will hit a certain house in the next 10 years is a percent distributed with mean 4. So we let this number as n. So this n follow percent distribution with lambda mean lambda is 4. Okay. Okay, and so the loss L will follow exponential distribution. Yeah, exponential distribution with let's say this is the lambda. So I put this as mu. Okay, and mean is 1,000. So 1 over mu means 1 over mu. This equal 1,000, right? Okay. So we want to find the variance of total loss. So total loss is like total loss T equal just L1 first loss plus second loss if we plus if we have n the loss we have happen n times, so this plus L in. So this in is not fixed, right? So we want to find those values. So we want to find Vt, okay? So here, this L is landing variable, and this N is also landing variable. So here we can regard those as we have a double landing variable. So double landing variable find the values. So we have this formula. So equal, let's say, so we just equal VE and EV, right? VE. So here ET. So when so other ones are here we have L and N. So N fixed, okay? N fixed. Plus so EV VT giving A. So this is the formula. So this is VE plus EV. Okay. So now we just apply. Okay. Okay. So I put it to here. Okay. Equal V. So at the first, E. What is this part? ET. For if N is fixed, N is constant. We regard N is constant. What is ET? So ET is just equal N multiply EL. So EL is this L. EL is 1,000. So this is just equal 1,000. Okay, right? So plus let's see. So Vt, if N is fixed, Vt. So if N is constant, so Vt, so values for L1 plus L2 plus Ln. So values is just N time. So just values add them up. So this values is 1 over mu square, right? So that's equal 1,000 square actually, right? So this is the values. Okay, so now we want to find those things. So V thus equal 1,000 square VA. So plus, so E thus equal 1,000 square EA. Okay, so what is VN? VN? So this N, let's say this N for Poisson distribution. So for Poisson distribution, we know variance and mean the same, equal lambda. So we can say that this is just equal 4. So this equal, this is 4, right? This is also 4. So put them together, so equal, these are the same, yes. So this equal A times 1,000 square, right? Okay, so now let's check this problem. So it says they have three driving arrows. So each one can result. Maybe like this arrow can cause the car accident or not cause a car accident. So cause car accident is says probability. So we can say if we have the arrow happen, saying 0.25, we will car accident. So here no car accident, right? So for if car accident happen, then the loss, so here the L loss will follow exponential distribution, and the mean is a point A. Okay. Okay. So for payment, it's not just the L, just payment is 70%. Okay, so what we want to find the values of the total only reimbursed loss. So this is just actually the 30%, right? 30% for loss. Okay. So we want to find the values for the total. So total depends on like how many L, how many loss, how many car accident happen. So could it be one, or could it be zero, could it be one, could it be two, could it be three, right? So we don't know this how many. So let's say n is number of car accident caused from there's 3 errors, right? 3 driving errors. So this n is actually is let's say this n is random variable. This n can be 0, can be 1, can be 2, can be 3, right? Okay, so the total unreimbursed loss T equals us 0.30 L, like maybe L1, or maybe if n equal to the so 0.30 L2, or so if there's n, so actually it's just the Ln, right? Okay, so this Vt is just like the previous problem, right? So this T involve 2 variables, L loss and also number of loss, right? So we have 2 variables. So we just use that formula. Let's say so Vt equal VE and EV. So VE ET giving the fixed n, so plus EV, yeah, EV, so T. Okay, so regard n is constant. So I put it here equal, so V, so ET. So what is ET? ET equal ET equals 0.30, and how many L's? N, right? N L. So for each L, mean is let's say mean is for each loss, mean is a point A. So this multiply point A, right? Okay, so plus EV. So this T when n fixed, so this value is so 0.30 square, and so we have n of them, right? Let's say VT is yeah. So V variance of the 0.30 in. So variance for L for loss variance is 0.80 square. Okay. Okay. So we can find this just equal. Okay. 0.3, 0.80, no, 0.24. So 0.24 square Vn, so plus this is 0. Also 0.24 square and En. Yeah. Okay, so now what we need to find just En and Va. So find En, Va, so we need to check the distribution for N. So this N is number of characteristics from 3 arrows. So there's a probability no, let's say probability no characteristic is so 7.5. We just put the 7.5 as 3 over 4. So there's 3 over 4 happens 3 times, right? And N equals 3 is 1 over 4 happens 3 times. So then we can find what is a probability N equal 1, N equal 2, so N equal 1. So this is just let's say P I put it here, N equal 1. So have among the 3 we have 1. One of them caused the car accident. So there's a probability equal. We just choose 3, pick 1. So this thing happens 1 over 4. Car accident happens 1 over 4. And not happens 3 over 2. So 3 over 2 square, right? So this is just the binomial distribution. And also we can find Pn equal 2. So plug in, so we think we can find those Vn and En. So this Vn and En, this N of followed by binomial distribution. So here maybe we don't want to calculate. So we can use the formula. So this N, we say N followed by binomial distribution. Okay. So here N is 3 and P is 1 over 4, right? Okay, so we know this Vn, no, sorry, En is just equal 3 times P, NP, right? And Vn equal NPQ. So equal the 3, right? N, the P is 1 over 4, Q is 3 over 4. Okay. Okay, so here we need to know the distribution for those things. So you don't need, so you can apply the formula, you can get to the solution quickly. Okay. So for the problem 150, we need to calculate this percentile, 95 percentile for payment. So this looks like that. We want to find cutoff point. Okay, we want to find a cutoff point. Suppose this is A, such that this part payment. Let's say the probability for payment less than A is 95%. So we want to find this cutoff point A. Okay, so let's check payment. Okay, so payment. So here let's say. So sometimes no car accident, 80% no car accident. So let's say the number of car accident, no car accident is point A, and more than one car accident is 0.0. So we can say the number of car accident in can only be like there's two cases, 0 or 1, because 2 or 3 we can regard it as probably 0, and the probably here is point A, next thing here point 2, right? So this is okay. So this is the number of car accident, and if car accident happen, the loss without deductible is exponential distribution. That means this. So we say the loss follow exponential distribution, with mean is this. Okay, but the payment we have deductible. Okay, so let's say that we just focus on payment. The payment less than A, we can have two parts. Okay, so there's a payment, there's probably equal. If N equal 0, the payment less than A, this should be for sure, right? So no, so here actually N equal 0, then N equal 1, such a chance 0.2. So for N equal 1, so we need to check the payment. So what is the probability? The payment is less than A. So this payment less than A. Okay, so payment less than A. So we just check. Okay, so we want to find a cut point. The payment is let's say like this, from 0 to 500, and we just suppose cut point here. This is payment is less than pay. So okay, so here the payment is X. Payment is L minus 5,000. So here payment is let's say, so at the point payment less than A, so less than A means L, this X. So this let's say we just payment. So this probability, so we just use integration. Okay, so this equal like from payment L from 500 to this point. So this point is 500 plus A, right? Then density function lambda is negative lambda x dx. So this equal 0.95. Oh, okay. Okay, here's 0. Yeah, here's 0. So 0, if there's 0, always okay. So actually, here we should be careful. Like payment. So here's payment is 0. So 0 should less than is always true, and then also include this part. So actually, we can the integration the low bound can be start from 0. Yeah. So we split it into two parts, from 0 to 500, then plus 500 to this cut point, right? Okay. Okay, so then we can find, okay, so this point, the divided point minus 0.8 divided by 0.2. So we find this this integration should equal 0.1 like 0.15 over 0.2, right? So this is, we can say this equal 3/4. Okay, so this integration is, let's say, so this integration, so we apply the formula for exponential distribution. So this is just equal 1 minus e negative lambda times 500 plus a. Okay, so this equals 3/4. Okay, so then we find this, I put it here, so this e negative lambda 500 plus a equal 1/4. Okay, so this e I'm sorry, lambda 500 plus a should equal just ln or negative ln 1/4, or just equal ln 4. Okay, so we find, so 500 plus a should equal lambda multiply this. So what is lambda? 1 over lambda. What is the lambda? 1 over lambda is this. So okay, yeah. So we can say this equal 1 over lambda divided by lambda. So this equal log 4 multiply 1 over lambda is 3,000. Yeah, 3,000. So we can find this a. Okay, so we finish those problems. So we can stop here, and thank you for watching. Thank you for your patience.